Second part on the section on polynomials called like and unlike terms. So, how does this look? First off, what are like terms? And like terms are when they have two terms that have the same variable, x and x, y and y, that kind of thing. And they also have to have the same exponent too. So x squareds and other x squareds are like, and whereas x squareds and x cubes are not. So with that known, let's test a few of these out and see which are like terms. Are these two like terms, 6x and 3x? Yes, they are. They have the same variable, and they have the same exponent too. They both have imaginary 1, so they would be a yes. 5a and a, are they like terms? Yes, they are. They both have imaginary 1s. You may remember from the grade 8 videos, if you watch those, I did circles and squares with like terms, and if they're both like each other, I would put the same shape around them. So, yeah, these would get the same shape when we collect them together. This is a tricky one, 3ab and 6ba. Well, what is AB? What are A and B doing to each other? They're actually multiplying each other. There's nothing in between, so they're multiplying. It's A times B. And remember, in multiplication, it doesn't matter what order you multiply it in. 5 times 3 and 3 times 5 are the same thing. So A times B and B times A are the exact same thing. So they're the same variables. This is yes, they are like terms. Okay, now here you've got A squared B and A and then B squared. Their exponents are different. You gotta have the same exponents. A needs to be squared and B has to have a power 1, but they don't. They're the exact opposite. So these are not like terms. These two, what do you think? They both have x's, but their exponents are different. Not like terms. Here, they both have a squareds, but this one has a b. This one doesn't have a b. So, no, not a like term. And how about this one here? A to the power 3, yeah, it's there. B squared, yeah, it's there. C squared, yeah, it's there. Yeah, it's in a different order, but like I said, when you're multiplying, order doesn't matter. And the 6 to the power 4, well, who cares about numbers with exponents? That doesn't affect whether they're like terms or not. It's just a number with those variables and another big number with those variables. So this would be a yes. Now for this, if you remember, this is a power raised to a power. So this would be, this is the same thing as saying 12 squared. Remember, this power is going to everything in here. That and that would be 144. And then that is going with that. So that's a squared. And this power raised to a power, you multiply them, is b to the power 4. And so once you've simplified it, you realize, they are the same. So those are like terms. Okay, let's collect like terms or combining like terms, the old circles and squares method from before. This time we're going to let you use algebra tiles. Again, you can only add or subtract two terms if they're like. If they're not like terms, then you can't mix them together. They're like circles and squares, or like apples and oranges. You cannot add them. So here, add or subtract. I'm going to show you the algebra tiles method first, then I'll show you my circles and squares method. So here, you have that plus that. First thing, get rid of the brackets, and when there's a plus sign in front, the brackets don't really cause anything. So which are like terms? Here, let's first get rid of the brackets. And which are like terms? Well, the 5x squared and the negative 3x squared are. Remember, the sign in front belongs to that term. So those two are like. may want to group them together. And those two are alike. I want to group them together. So we rearrange it so they're grouped together. And 5x squared minus 3x squared is the same thing as 5x squared. And then, so 5 yellow big squares. And how many of these? What's that going to look like? 3 red squares. And when the reds and yellows cancel each other out, you're left with 2x squared. Here you would have, what shape would this be? Just a regular X, that would be yellow rectangles, 3 yellow rectangles, and 6 more yellow rectangles. Add them up together, you get 9 yellow rectangles. 2x squared plus 9. Now the other way of doing this would be circles and squares method. The x squareds are like each other, so let's put circles around them and the sign in front of it. The x's are different, so let's put squares around them and the sign in front of it. We just put them together. We read it together. I know it's not a very good circle, but 5x squared minus 3x squared, 5 minus 3, 2x squared. That's an ugly 2. And then here, 3x plus 6x. 3 plus 6 is 9, so it's just 9x. Whatever way you like to see what the answer is, that is what the answer is. Exactly the same. Pick your poison. Which one do you like? Use it. Okay. Using algebra tiles to do these. Okay, I'll quickly with the algebra tiles show you how to do this. Again, that and that are going to be like terms. 6 yellow rectangles plus 9 little squares, negative 4, that's 4 red rectangles, negative 5, 5 red rectangles. We do the cancel out thing, the 0 pairs, those 4 cancel out those 4, and these 5 will cancel out 5 from there. And you're left with 2x plus 4. Circle and squares method would look like this. Circle, circle, square, square. Oh, I know that it looks ugly, but go with me. Okay, so 6 minus 4 is 2x, and that's supposed to be a square. 9 minus 5 is 4. Either way. Okay, for this one here, using algebra tiles, 6a looks like that. Negative a squared looks like that, it's red. Positive 4a looks like that. Negative 2 or red looks like that. And positive 3a squared looks like that. Combine the, cancel out the opposite colors. Boom, gone. And there's no other opposites of these, no other opposites of these, no other opposites of these, so then the answer just becomes 2a squared. Remember, there are a's here, that's why. But it doesn't really matter. You can call them x's if you want. And count up the number of x's. There are 10 of them, and there's a negative 2 there. Using the circles and squares method really quickly, let's put circles for the a, the single a's. Let's put squares for the a squareds. And, oops, sorry, I should have put the sign in front of it as well. That's what you're supposed to do. Also do the sign in front of it, don't be sloppy, like I was there. And let's put a triangle around that. So the circles, 6a plus 4a, 10a. The a squareds, negative 1a squared plus 3, you're down 1, you're up 3, positive 2a squared, and you're just left with a constant negative 2 left behind. Again, it's best to put the exponent first, then just the letter, in the number in that order. It's not wrong if you don't put in that order, but it's best if you do it that way. Simplifying these, again, you know, it gets to a point with algebra tiles, just like, yeah, I get it, let's move on. So let's just use circles and squares here. Who are like terms? 5AB and this here, BA, are like terms. Remember, it doesn't matter the order of the letters. That is going to go with that. The constants, we have an 8x, sorry, just an 8 there and a 12 there, so the numbers get a box around them, let's say. The a squareds, there's only one of them. Let's put a triangle around them. And plus 9a, what's left? Let's put a cloud around them. So either algebra tiles or the circles and squares method, pick whatever you like. That minus that, 5 minus 3 is 2, and you can call it AB or BA, doesn't really matter, it doesn't mean the same thing. Let's call it AB. Let's take care of the squares here. 8 plus 12 is 20. That's why it's important to put the sign in front of it, don't forget that. The triangles are only one of them, so it's just minus 3a squared. And you get the cloud, which is plus 9a. There's only one of them. In the nice order, you're supposed to have the a squared go first, so the squared term go first. 3a squared. And then out of these two, it doesn't really matter. I guess we'll put the 2ab. It should go by degree. This has a degree of 2. That has a degree of 2, if you remember your order of polynomials from before. Degree of polynomials. So we'll have positive 2ab, and then this, which is degree of 1, plus 9a, and then that, which doesn't have degree at all, it's just a constant, positive 20. So that's how I would do it. It's a 2. They do a similar thing. We'll let them do it their way on the second one. Okay, so what they did here is the m's cubes, they grouped them all together. So they grouped all the m cubes together, the mn's together, and there's only one m, and they put the m's together. That gives you 17 mn, and negative 10 plus 15 gives you positive 5. And nothing else you can do with that, so you're done. And this last one here, there are no like terms. X cubes, no one else. Regular x's, nobody else. X to the 4, no one else. X squared, no one else. Just constant, nobody else. So what you should do is put in the right order. Again, you rearrange from the highest to lowest degree. So that will go first. Yeah. So that will go first, the cube will go second, the squared, the single, and then the constant. Okay, this let's not worry about. Let's jump to the skill testing questions. Here they are. For this one here, just circle which of these are like terms with 6x squared. Give me the expression that you get after you simplify these algebra tiles, and using any method you like, simplify that. All right, thank you very much. Bye-bye.